Is that a slang word? I don't know.
Fracking, I think, has something to do with the oil and gas industry and how they, a method they use to drill down into the earth.
I have no idea fracking.
Especially in Capel.
Fracking. It's that thing in the earth, right? Like
All I have are
fracking.
victimless crimes.
It's up in Canada, like down to the, like Texas, like it's something under the earth. I don't know.
Okay.
Darn. Fracking.
Yeah.
I don't know. It's like freaking.
Shoot.
Laughing really loud.
When someone is dressed all weird, like, you know what I mean? Stands out from the crowd.
Fracking is another way of saying hydraulic fracturing. Fracking refers to the procedure of creating fractures in shale and rock formations by injecting fluid into cracks to force them further open. The larger openings allow more oil and gas to flow out of the formation and into the well where it can be extracted.
So we have Mr. Goodner here, and he is a geologist. All right, we have a couple questions for you.
Okay.
Number one, can you give us a simple example of how they extract natural gas in Texas?
Natural gas has been extracted in Texas for a long time, almost 100 years. And through most of that time, it's extracted from limestone and from sandstone.
Mm-hmm.
Natural gas is prolific throughout Texas, and those are the main reservoir types for it. Throughout most of that period of time, the shale, and I'll use Barnett as a specific example, the Barnett Shale has served the purpose of being a source rock and as a seal over reservoirs that are made of sandstone or limestone. Since 1997, it has developed into a third useful tool for the industry in that it's now a very tight but gas-filled reservoir type. And the only way that you can get the gas product out of the shale is to fracture it by putting down water filled with sand. You shoot bullets into the shale to break it, make it open up, and then pump high pressure fluids with sand in to open the fractures. So that's how you get the gas from the shale.
Okay. All right. Okay. So we're kind of focusing on the water aspect of it. So how can extracting be a threat to the underground aquifers?
It depends on what part of the country you're in. If we're talking about the Capel area and we're talking about the Barnett Shale, it is not a threat to contaminating aquifers.
All right.
Unless, as we said in class, if you fracture it improperly, the fractures extend out beyond the Barnett Shale, then you get into the Ellenberger, and that is an aquifer. But I don't think you would become contaminated. I think you would just lose your well, and you'd have to walk away from it. The bigger concern from the water aspect is the amount of water that you're using. Texas is under drought conditions and has been now for quite some time, and it will be into the foreseeable future. And if you drill a well to produce gas from the Barnett Shale, it's going to require 8 million gallons of water, plus all of these chemicals that we talked about in the sand. So it's more the amount of water that's being used for this purpose, and where that water is coming from is probably the same source as our drinking water, which is the reservoirs. It'll draw them down. And then if the rain is unpredictable, then you've got depleted reservoirs.
What precautions do y'all take to make sure that the water supply is protected as you're drilling?
Mostly with the casing system that's used. When you drill a well, you penetrate the surface and then put down a string of surface casing, which is huge pipe. It's at least that big around, and cement it into place so that from that point on your drill bit goes down through that pipe, and you continue to put down other strings of casing all the way down the well, and cement them off properly, and it will protect any rock that you go through. It'll also help protect your well from cave-ins and blowouts if you hit some high pressure zones.
But whenever you drill through the aquifer, how do you keep the water from escaping and leaking out?
When you come through the aquifer, that's what I said about the casing string. That's important. The aquifers are shallow. They're generally less than 1,000 feet, and your target for the gas is down more than 10,000 feet. So when you come through the upper zones, you just need to drill carefully through those and cement them off, because you don't want water coming into your well.
Could human error ever lead to water pollution?
Yes, it's possible, and you have to be very careful, and mistakes happen. We saw what happened with the BP well blowing out in the Gulf of Mexico and what a mess it made. Human error is always possible. You just have to take precautions and be as smart as you can.
What's the most common error that could happen, the easiest error to make when drilling that would affect the water?
In a gas shale situation, if the shale is too thin, and again, this is not the Barnett. The Barnett is a very thick shale. It's over 500 feet thick. If you're drilling for a thin shale and you try to fracture it, it's hard to stop from fracturing the superjacent and subjacent formations. And when you do that, that can cause problems.
Okay, so after you have done the whole fracking process, where does the leftover water go, like the fluid?
It goes into a pit at the well site, and this is a very temporary situation. It's only during the drilling period, and the drilling only goes on generally for 1 week or possibly 2. When everything is finished, the fracture fluids are gathered up and trucked away, and then the operating company needs to report to the Texas Railroad Commission to prove that they've done it properly, and they are inspected.
What is your overall opinion on the Keystone Pipeline?
My personal opinion is that I don't see a problem with it as long as its route is very carefully controlled so it does not go through national parks and environmentally sensitive areas, or through areas which are earthquake prone, so that some kind of a seismic event could fracture the pipeline. Generally, oil pipelines are safe. They do not leak. In fact, they are monitored annually. They close down the pipeline. They'll put a camera down through the center of it and x-ray equipment and x-ray the thickness of the pipe. If they find any weak zones, they correct those immediately. American industry oil pipelines generally do not leak. It's very different in Russia. They've got thousands of leaks per year over there in those pipelines. Also, the oil pipeline is not explosive. It's not such a flammable fuel as gas is. There's very commonly you'll see gas line explosions, but with oil that's not the case.
Overall, do you think that continuing natural gas extraction has a long-term positive or negative effect in Texas and this area?
Yeah, it has a positive effect long term. Again, if it's properly controlled, and if you are, I'm an old guy, and in the oil industry, we've always taken fuel from sandstones and limestones, and that's the situation I'm comfortable dealing with. This shale technology is new, and it's being developed as we go. Having to break a rock to get the fluids to flow to a well is something we've never had to deal with before. The breaking of the rock can be done safely as long as you're doing it intelligently, as long as you're not getting too close to the edge of the formation, so that you're moving outside into something that you have no control over. I think that there is so much gas resource contained in these shales that you can't avoid producing them. The country needs the energy, and it's there. The landowners that have the mineral rights can certainly use extra income. but you don't want to be contaminating your drinking water. And in parts of the United States, this has happened. Specifically, I'm thinking of Colorado and Pennsylvania.
Alright, now that you've heard Mr. Goodner's interview, we're going to go into more detail about the problems of water pollution. The main problem with the fracking process isn't the contamination of the water, it's the amount of fresh water used. In order to drill one well, it requires over 8 million gallons of water. This is a major problem in Texas because we are in a drought, so using this much water is not in our best interest because it is threatening our water supply.
We decided to visit the natural gas drilling site on Bass Pro Drive in Grapevine. When we visited there were not any workers on the site, nor were we able to get very close. However, we were able to get a picture of one of the 20,000 drilling wells in the Dallas area. This is a diagram of how fracking is done. Whenever they first drill, they have to go through an aquifer, and although they use cement casing to keep the fluid out of the aquifer, this doesn't always hold. Shifts in the earth and human error can cause the cement casing to break. Also, you can see that if the shale is too thin when they fracture it, the fracking fluid can go into other levels of the earth and possibly get into the aquifers. If this happens, they have to leave the well, and it is a waste of money and the land.
This is a waste pit where all the water goes after the drilling. As you can see, the water looks unnatural. Although the water is eventually cleaned and chucked away, the toxic chemicals can seep into the ground and evaporate into the air. This can cause future health issues for animals and plants and also people around the area.